Good afternoon everyone. Today I am going to discuss about the computer organization subject unit 4 part 2. So coming to the topic, so memory system organization. So in this we are having, in the part 2 we are having memory system organization. We are having some topics, that is memory hierarchy and main memory, auxiliary memory, cache memories, virtual memories, memory management hardware. These are the different contents we are having in the memory system organization. Now I am going to discuss about the first topic, that is memory hierarchy. So what is meant by memory hierarchy? So this is the basic concepts of this memory system organization. So I am going to explain now in briefly about this memory hierarchy. So this why we are using memory hierarchy? The memory unit is needed for storing. The memory unit is needed for storing the programs and data. So why we are using memory unit? The memory hierarchy is nothing but, in this we are having the memory unit, and this is mainly used needed for storing the programs and data. The memory unit that communicates directly with CPU is called main memory. So what is mean here? The memory is the main memory. The memory unit is needed for the purpose of storing the programs and data. So and this memory unit is communicate directly with the CPU. So in this diagram, see here, this is the main memory. So this main memory is called memory unit. So this is mainly used for storing the data and programs, and in this this memory unit is directly connected to the CPU is called the main memory. So devices that provides here, devices provides backup storage are called auxiliary memory. So devices here at the left side we are having the auxiliary memory. So devices that provide backup storage are called auxiliary memory. The most common auxiliary memory devices used in computer system or magnetic disks and magnetic tapes. So they are used for storing system programs and large data files and other backup informations. So what is the use of this auxiliary memory? So these devices, the devices that provide the, so these devices will provide the backup storage are called auxiliary memory. So auxiliary memory is located at the left side of the diagram, and this auxiliary memory is most commonly used this auxiliary memory device is used in computer system or magnetic tapes and magnetic disks. So they are used to store the system programs, large files and other backup informations. So that is the use of auxiliary memory. So now we have discussed about the two things which is available in this auxiliary memory and memory. These two things we have discussed. Only programs and data currently needed by the processor. So only programs and data, only programs and data currently needed by the processor reside in main memory. Other information is stored in auxiliary memory. So what they are saying, programs and data, current data, those are things are stored needed to processor and reside in main memory, and other information are stored into the auxiliary memory and transferred to the main memory when needed. The main memory occupies a central position by being able to communicate directly with the CPU and with auxiliary memory devices through the input-output processor. So when programs are not residing in main memory, which are needed by the CPU or bought from auxiliary memory, programs are not currently needed. The programs are not currently needed in main memory are transformed into auxiliary memory to provide space for currently used programs and data. So a special very high speed memory called a cache memory. So it is sometimes used to increase the speed of processing by making current programs and data available to the CPU at the rapid rate. So this is the main working of this memory hierarchy in a computer system. Okay. So this is the diagram of memory hierarchy. So what is the main use of cache memory? This cache memory is employed in computer system. This cache memory is mainly employed in computer system to compensate for a speed differential, between main memory, access time, and processor logic. The cache memory is used for storing segments of programs currently being executed in the CPU and temporary data frequently needed in the present calculations. Okay, so the storage capacity of the memory increases, the cost per bit for storing binary information decreases, and the access time of the memory becomes longer. So the auxiliary memory has a large storage capacity. It relatively inexpensive but has low access speed compared to main memory. So we are talking about the difference of main memory and auxiliary memory. The auxiliary memory has the large storage capacity to store the data, and it is very expansive but low access speed. Access speed is very low when compared to main memory. The cache memory is very small, relatively expansive, and has very high access speed. The memory access speed increases, so does its relative cost. Okay, so overall goal of using the memory hierarchy is to obtain the highest possible average access speed while maximizing the total cost of the entire memory system. So this is called the memory hierarchy. Okay, so this is the total explanations of the, and this is the main goal of this memory hierarchy. So next, multi-programming. So what is mean by multi-programming? In this we are performing the multi-programming. Many operation systems are designed to the CPU to process a number of independent programs concurrently. This is called multi-programming. Refers to the existence of two or more programs in different parts of the memory hierarchy at the same time. So in multi-programming system, one program is waiting for input or output transfer. There is another program ready to utilize the CPU. There is a, so in multi-programming system, when when one program is waiting for input and output or output transfer, there is another program ready to utilize the CPU. So computer programs are sometimes too long to be accommodated in a total space available in the main memory. A computer system uses many programs, and all the programs cannot reside in main memory at all times. A program with its data normally resides in auxiliary memory. When the programs or a segments of programs is to be executed, so it is transformed to the main memory to be executed by the CPU. Okay, the part of the computer system that supervises the flow of information between auxiliary memory and main memory is called the memory management system. So in this this is memory management system. Next, coming to main memory. So what is mean by main memory here? In this main memory is relatively large and fast memory. Main memory is a relatively very fast and large very fast memory used to store the programs and data during the computer operations. So main memory is made up of RAM integrated circuit chips. So the main memory is mainly made up of RAM integrated circuit chips, but the portion of the memory may be constructed with ROM chips. So the main memory is made up of RAM integrated circuit chips. Okay, so but the portion of the memory may be constructed with ROM chips. Okay, so in this having the semiconductor RAM memories. So what is mean by semiconductor RAM memories? So a RAM is used to designate read and write, distinguish it from ROM. RAM is used to designate read and write to distinguish it from ROM. Okay, RAM is read access memory and ROM is random access memory. RAM is random access memory, ROM is read only memory. Okay, so RAM is used for storing the bulk amount of programs. So what is the main use of RAM? It stores the bulk amount of programs and data that are subject to change. Okay, so the RAM is used for storing the bulk amount of data or programs that are subject to change. The RAM portion of main memory. So in the main memory we having the RAM portion is needed for storing an initial programs called a bootstrap loader. It's called the bootstrap loader. It means what? In the main memory having the one portion is the RAM. RAM portion is used mainly in order to store the initial programs called the bootstrap loader. The bootstrap loader is a program whose function is to start computer software operating when power is turned on. Okay, so that is called the bootstrap. What is meant by bootstrap here? The bootstrap loader is a program whose function is to start the computer software operating when the power is turned on. Okay, so that is called the bootstrap. So that is initial program that is storing into the RAM portion in the main memory. Okay, so RAM is volatile. Its contents are destroyed when power is turned off. So RAM is volatile. When the power is off, the complete content of the RAM is destroyed. Okay, so RAM chips is better suited for communication with the CPU. So RAM chip is better for communication with the CPU. The features is a bidirectional data that allows the transfer of data either from memory to CPU during the read operation or from CPU to memory during write operation. So when CS1 is equal to 1, when CS1 is equal to 1 and CS2 is equal to 0, the memory can be placed in write and read mode. So when the when I put condition CS1 means chip select 1, CS2 means chip select 2. Okay, CS1 and CS2. CS1 is a chip select 1, I provided the value 1, and CS2 is a 0. The memory can be placed in a write or read mode. Okay, so the RD means what? RD and WR. RD means read and write. So the read and write signals control the memory. The read and write signals control the memory operations as well as the bus buffer. The bus buffers associated with the the bus buffer associated with the bidirectional data bus. So when the read input is enabled, the memory stores a byte. The memory stores a byte from the data. The memory stores the byte from the data bus into the location specified by the address input lines. When a read input is enabled, the content of the selected byte is placed into the data bus. And in this having this is the diagram of RAM and ROM chips which is available in there. This is the portion of the main memory. Okay, na? So this is the complete explanation of this. The capacity of the memory is 128 words. The capacity of memory is 128 words of 8 bits. So in the middle of the diagram you see this, I have 128 into 8 RAM. So that is called the capacity of the memory is 128 words of 8 bits. So 1 byte per word. So this requires the 7-bit address and 8-bit bidirectional data bus. Okay, 7-bit address and 8-bit bidirectional data bus. The read and write inputs specifies the memory operations and the chip select CS. That is two chips means chip select 1, chip select 2. These two chips control the inputs of R for enabling the chip only when it selected by the microprocessor. The read and write inputs are sometimes combined into one line labeled read and write. One line labeled read or write. When the chip is selected, the two binary states in this line, the two binary states in this line specifies the two operations of read or write. So the integrated RAM chips are available. The integrated RAM chips are available in two possible operation modes. So operation modes of read and operation modes, that is static and dynamic. So what is mean by static RAM? The static RAM consists essentially of internal flip-flops that stores the binary information, and the static RAM is easier to use. The static RAM is easier to use and has shorter read and write cycles, So this is called the static RAM. Next having the dynamic RAM. So what is mean by dynamic RAM? The dynamic RAM stores the binary information in the form of electric charges that are applied to capacitors. The capacities are provided inside the chip by MOS transistors. The stored charges on the capacitors tend to discharge with time, and the capacitors must be periodically recharged by refreshing the dynamic memory. So the dynamic RAM offers reduced power consumptions and large storage capacity in a single memory chip. So having the difference of static RAM and dynamic RAM. So in the static RAM consists essentially of internal flip-flops that are store the binary information. So that is called the static RAM. And in the dynamic RAM stores binary information in the form of electric charges that are applied to capacitors. The capacitors are provided inside the chip by MOS transistors. The stored charges on the capacitors tend to discharge with time, and the capacitors must be periodically recharged by refreshing the dynamic memory. So that is called the dynamic RAM. Next is a static RAM. So coming to static RAM is easier to use. So coming to dynamic RAM. So the dynamic RAM offers reduced power consumption. So third one, in the static RAM, it has a shorter read and write cycles. So at the side of dynamic RAM, it has large storage capacity in a single memory chip. So this is the difference of static and dynamic RAM. So this is the two things which is available in the RAM chip. So that is two operating modes, that is static and dynamic. Okay. So next coming to read only memory, ROM chips. So what is mean by ROM chips? So this is the ROM chip. So ROM is used for storing the programs. Why we are using ROM? For storing the programs that are permanently resided in the computer and that do not change. So the RAM is mainly used for storing the programs that are permanently resided in the computer and don't change. So the content of ROM remain unchanged. The content, whatever the content we are having, that content of the ROM remain unchanged after the power is turned off and no on again. So if the RAM is a volatile, ROM is a non-volatile. In the RAM, if the power is off, the complete content is destroyed. Okay. So in the ROM, if the power is off, the content will be unchanged. It remains same, whatever the data we have stored in that, the data will be remain same. We don't have any destroy in that whenever the power is gone. So up to power is on again. Okay. So that is why it is a non-volatile. ROM can only read the data bus only in an output made. So this is the ROM chip, and in this ROM chip, the chip size is same. For the same size chip, it is possible to have more bits of RAM. And than the RAM. It is possible to have more bits of ROM than of RAM because of internal binary cells. Because of internal binary cells in ROM occupy less space than in RAM. So ROM occupies less space than in RAM. For this reason, we have specifies a in the diagram we specifies a 512 bytes ROM, while the RAM has 512 bytes. So the 9 address line specifies. So in this diagram, if you see that in the ROM chip, I have CS1 and CS2. This is the chip select 1 and chip select 2. At the middle ROM, I having the 512 bits into 8 bits. So okay, in the 9 address line specifies any one of the 512 byte stored in it. The two chips select input must be CS1 equal to 1 and CS2 is equal to 0 for the unit operate. Otherwise, the data bus in the high impedance state. Okay, high impedance state. So here I having the difference of RAM and ROM. So what is mean by RAM? So RAM is used to designate read or write. RAM is used to designate read or write to distinguish it from the ROM. So that is called a RAM. Coming to the ROM. ROM is used to designate read operation only. Designate it does both. RAM will be does both read and write operations. In the ROM we perform only read operation. So that is the difference. So coming to the RAM. RAM is used for storing the bulk of programs. Storing the bulk of programs and data to the subject to change. So that is called a RAM. So coming to the ROM. ROM is used for storing the programs that are permanently resided in the computer and don't change. So in the RAM, whenever the power is off, the complete data will be changes. It means destroyed. Okay, now in the RAM, whenever the power in the computer, whatever the data we have stored, that doesn't change. Okay, so that will be stay permanently. Okay, coming to the RAM. RAM is volatile. The content will be destroyed when the power is turned off. ROM is non-volatile. Its contents are not destroyed when power is turned off. So in the RAM, it is a bidirectional data bus. It is a unidirectional data bus. ROM is a unidirectional data bus. So coming to the RAM. RAM portion of main memory is needed for storing the initial program called bootstrap loader. Okay. So this is the difference of RAM and ROM. So next coming to memory address map. So what is mean by memory address map? The addressing of memory. The addressing of memory can be established by the means of table that specifies the memory address assigned to each chip. So this is called the memory address map. Memory address map. So here I having the table. This table is called the memory address map of micro pro computer. So this addressing in this we are having the addressing of memory can be established by means of table that specifies the memory address assigned to each chip. This is called the memory address map. A computer system needs the 512 bytes of RAM. A computer system needs how much? 512 bytes of RAM and 512 bytes of ROM. Both things needed. A computer system needs both 512 bytes of RAM and 512 bytes of ROM. So there are 16 lines in the address bus. The table shown only 10 lines. Because the other 6 are not used in this example. Okay. So and are assumed to be 0 and are assumed to be a 0. So the small x under the small x under the address bus. Here if you see the address bus in the table, so we are using the small x. So the small x under the address bus lines designates that those lines must be connected to the address inputs. So whatever the x's we are seeing in the table, so that a small x is the address bus lines, designate those lines must be connected to the address inputs in the each chip. So RAM chips have 128 bytes. In the RAM chip we have 128 bytes and need 7 address lines The ROM chip has 512 bytes and needs 9 address lines. Okay. So the X are always assigned to low order bus lines 1 through 7 for a RAM and lines 1 through 9 for a ROM. It is necessary to distinguish between 4 RAM chips by assigning to each a different address. So when line 10 is 0, the CPU selects the RAM, and when this line is equal to 1, it selects the ROM. So the table clearly shows that 9 low order bus lines constitute of memory space for RAM equal to 2 power 9 is equal to 512 bytes. So in this so the first hexadecimal digit represents lines. The first hexadecimal digit represents lines 13 to 16 and is always 0. So the next hexadecimal represents 9 to 12, but lines 11 and 12 are always 0. So these X represents a binary number. This X represents a binary number that can range from all zeros to and all ones value, all zeros and ones value. So next coming to memory connection to CPU. Memory connection to CPU. So here this is the diagram of memory connection to CPU. So RAM and ROM. Here we are having the RAM and ROM. Okay. So the RAM and ROM chips are connected to CPU. RAM and ROM is connected to CPU through the data and data address buses. So RAM and ROM is connected to CPU through the data and address buses. So this configuration gives the memory capacity of 512 bytes of RAM and 512 bytes of ROM. Okay. So each RAM receives the 7 low order bytes of address bus to select the one of 128 possible bytes. The particular RAM chip select is determined from lines 8 and 9 in address bus. So this is done through 2x4 decoder whose output goes to the CS1 chip select 1 input in each RAM chip. So when address lines 8 and 9 are equal to 0, 0, the first RAM chip is selected, and when 0, 1, the second RAM chip is selected, and so on. The read and write output from the microprocessor are applied to the input of chip RAM of each RAM chip. The selection between RAM and ROM is achieved through bus line 10. The RAMs are selected when the bit in this line is 0 and ROM when the bit is 1. The other chip is selected input in the ROM is connected to read. Control lines for ROM chip to be enabled only during the read operation. So the address bus lines 1 to 9 are applied to the input address of ROM without going through the decoder. This assigns address 0 to 511 to RAM and 512 to 1023 to ROM. So the data bus of the ROM has only an output capacity, whereas the data bus connected to RAMs can transfer information in both directions. So this is the diagram, explanation of this diagram, that is memory connection to CPU. Okay. Next we having some types of ROM. We having some types of RAM. ROM. So PROM. PROM is programmable read-only memory. It is a memory chip on which data can return only once. Once a program has been written onto programmable read-only memory, it remains there forever. It remains forever. So unlike RAM, programmable read-only memory retain their content when computer is turned off. Okay, the difference between programmable read-only memory and a ROM read-only memory is that programmable read-only memory is manufactured as blank memory, whereas ROM is programmed during the manufacturing process. To write data onto the PROM chip, you need a special device called PROM programmer or PROM burner. The process of programming a PROM is sometimes called burning of programmable read-only memory. Next, another type is EEPROM. EEPROM means erasable programmable read-only memory. So, what is mean of this? So, it is a special type of memory that retains its content until it exposed to ultraviolet light. So, the ultraviolet light clears its content, making it possible to reprogram the memory. To write to and erase an EEPROM, you need a special device called PROM programmer or PROM burner. So, this is the another type. So, third type is a E2PROM, is electrically erasable programmable read-only memory. So, it is a special type of PROM that can erase it by the exposing it to electrical charge like other type of PROM. E2PROM retains its content even when the power is turned off. Also, like other type of ROM, EEPROM is as fast as RAM. Okay, so this is the types of ROM. So up to here we discussed about the ROM chip. So in the next class we will discuss about the auxiliary memory. Okay, so and we having some more. This is the secondary storage, and this is the magnetic tape, and this is the write, and this is the levels of the writes and associate memory and examples. This is the diagrams of this, and this is the cache memory and associative direct and set associative mapping. These are the different things available. Virtual memory, and this is the diagram, and these are the things which is I am going to explain in the next video class. Okay, so thank you for listening this topic.